Welcome friends, I'm Rahul Shimkar. I'm working as a project engineer in VNIT Simcenter of Excellence, Nagpur. So now we will learn how to create the material. For that we need to have particular part file. Instead of taking or using the original previous part file, I will create a small box. For that, as usual, we will do the light camera action volley commands, which are roll. Here in the roll advance, say okay. It will these two commands will help you to make available or visible all the required instructions or command on the ribbon bar. Even if you don't find some in commands or features, you can right click in on ribbon bar and from there you can add it. So presently we don't require, so instead of opening I will create a new. Here I have to give the units as well. I will keep this unit millimeter as it is, or we can change it to inches anyway. So Simcenter Nastran, as usual, I will use the solver. Then here I am presently in the simulation environment, but I want model environment. Again I have to change this unit. You can even keep a millimeter, no need to worry. Software also takes care about these units, but finally if you will have, let's say, particular project and one, let us say, one data we have in inches and one data we have in millimeters, and then that will create a problem or confusions. To avoid that, we can choose one unit everywhere. So I'm keeping this name as it is. You can change it. And yes, from here we will create a new folder, so where as usual we keep all data in one folder, like all files related to this project on linear. Okay, yes, I have given name as non-linear material. So in this folder I will save all the files. So new file I'm going to create in this folder itself. Say okay. Now very first I will change this background of graphics window to dark. Now again going to the home tab. Here in the more group you will find a block option. So I'm giving 800 100 such these dimensions, and now this block is ready. So for this block I want to give new material. So here you can see I am in the modeling environment. I will go to the pre and post environment from the applications tab. Then now we will find these different options. What I will do, I will create FEM and SIM files here itself. So create idle as part file. Yes, I want it. All visible, bodies to use, then geometry as it is. Simcenter Nastran solver analysis type structural. No need to change anything here. Just say okay. Here we will change the solution type from linear to non-linear. So here solution 106 non-linear. static global constant. See this global constant, if it is not present, then you cannot use multiphysics problems, solve the multiphysics problems like from one field. If let us say you want to take data of one field from one solution to another solution, so in if you have crack version, then you must need to check. But for now, we don't require this global constraint. Fortunately, we have it in my system at office because this is a commercial version. Selecting non-linear static global constraint, create solution. Here again, no need to do any change, as it is. Keep everything. Just I'm checking everything. It's all right. I'm clicking on OK. Yeah. Then I will go to the fame file, right? Because there I want to do the material and properties, physical properties. So in this here you can see now fame part is the work part, but displayed part is the sim file. So I will make this fame file as a displayed part as well. Even though we are not going to do so much abstraction or idealization, we have not done anything, but still we can do the abstraction. Before that, I will directly go to the material management, or manage the material from this home tab. In the properties group, you will find the manage materials option. So what I am going to do, I will copy the properties of existing material in it. Let us say for steel, because for steel I have done one experiment on UTM, universal testing machine. So series of values I have for the stress and stress, corresponding stress value and strain values. So at least 6 to 10 values if you have, then you can use it to feed to create a new material. See, now I'm right clicking on the steel and I'm copying it. So once you click on copy, automatically new pop-up window will open. So from here we can add our values or change our values. Let us say I don't want to change this value in large amount. So for simplicity, what I am doing, I'm changing just last 2-3 digits. So here I'm putting 8. So because I don't purposefully want to change the properties very much, I'm keeping this Poisson's ratio 0.29, Young's modulus I have given. And then remaining properties I will keep as it is, because the new material is again a steel. Then from this stress strain H values, here I am going to add the values. So I will click on this equal to sign in front of this stress strain option. Here I will create a new field, and from new field I will create a table. So very first click on the dependent domain before going to do any changes in this independent domain. Click on dependent domain. Here we are going to keep this stress value as dependent itself. No need to do any change. Like if you know the or remember the stress strain curve, from that you can correlate this thing, dependent quantity and independent quantity. On y-axis we keep stress, so it is a dependent quantity. And now on independent, here I will select strain, so it is the independent quantity. If you know why we keep stress on y-axis and strain on x-axis, then only you will able to get this concept, because stress is dependent on this strain value. So that's why we keep stress on y-axis and strain on the x-axis. So here also I'm keeping same things. Independent domain is strain. Now I will go to define the values or give the measured values which I have taken or measured from the experiment, from the UTM, universal testing machine. So I'm here giving the values which I have already taken. So I have it with me and I will add those values. And keep in mind that after adding every value, don't forget to click on tab. Let's say at the last, if you put the value and don't click on tab, it will not store that value. First is 0.0 just, then 0.0.001, excuse me, 34970. Zero point zero zero 0.005. Zero 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 tab 0.01 43750. Zero point zero one five. At least 6 values or 8 values we should have. 0.03550. So after, if I will not click tag, it will not take this value or will not store this. So don't forget to click on tab. So now I have given all these values, stress strain values. So it will draw a stress strain curve, and from that it will, from the linearity or the equation of line, it will find out all the relevant values in that till this limit, or let's say proportional limit, or it will find the all the stress strain or stress values specifically. I'm clicking on OK. Here, from here I can change the name. Let's say non-linear, still underscore NL I'm giving name. Again, this initial endpoint I will give that value also I have. So it is not like that you will add any values and you will get proper results. So we should have the proper values from the experimental results. Then only we can design new material. Is 750. So I have given these values, I'm not sure whether it will create because I have missed this value. Anyway, let's try. I hope it will take. And yeah, we have to keep in mind the uh, units of all these. So it should be LBF per m square. It is in KPA, alright. Stress strain was properly given. And once again we can check that H values of this edit button. Yeah, it is created. Alright, I'm clicking on OK. Now you will find this material in the local material list. So previously we were if you will, now I'm closing it, you will not directly see in the original list. You have to go to the local material list. Again, here you can find this name, and if you want you can even change it, rename it from here. So I'm closing this window. Now what I will do, I will use this material to allocate to this particular geometry. Before that, what I will do, I will create a mesh collector. Let us say 3D analysis I want to do. Then from here I can able to choose that material inherited. In front of inherited you will find this button to choose material. So in this library you will not find it, so you have to go to the not here, in the local materials. Here it is the material, so click on OK. Now it is allocated. Here you can see still non-linear. Now I will click on OK and we'll say OK again. Now rest all things are very similar as usual. We will do meshing. So let's say I'm meshing it in 3D elements. Body I'm going to select like this. I will keep C tetra 10 mesh elements type. So element size I will keep this automatic. Then here the name is same, automatic creation mesh collector. Here you can find that this solid one we are going to mesh. Let's say OK. Then you can find it have created a tetrahedral mesh. And finally I will go to the sim file to apply loads and constraints. See, from here I will navigate. So atlas part file, this is the sim file. If I will double click it, this will become the displayed and work path. Presently film is the displayed and work path. So I'm double clicking on it. Here we are in the sim file. Here I will find the option for constraints. Let's say I'm applying fixed constraint on this side. From here we can also choose whether which type of edge or face I want to select, or one more filter is here. This is polygon face. Okay, I already selected, so say OK. If you can find here, the constraints are created. These are the corners highlighted, or from this constraint or the simulation navigator you can even highlight it by clicking on it. Now I will apply load. Going to the load constraints. Let's say I am applying some force on this face. Again I will select polygon face, not edge, polygon face. In this face I'm applying some force. Direction I will keep XC. Okay, not able to select. So what I will do, instead of force I will apply pressure, because I have selected face, that's why it was not able to select give the force. Now see here, I will give the pressure value 0.2. okay, you can see this representation. So we have applied some pressure here. You can apply the load as well, but just I missed while selecting the face, and the load value also I did not given, that's why it was not active. We'll try it once again after solving this. Now see, in the results there are no results. Once I will click on solution, solve, after right clicking on solution we have option to solve, it will give the results. So solution, now it is complete. We can close all these windows. I hope here we can find the colorful icon in the results tab or results menu. So here we have some results in game with respect to displacement, rotation, stress, strain, equivalent plastic strain, and all, non-linear stress as well. As usual, we will see one of the result by double clicking on it. So these are the values of results. If you want, you can even see the animation. This is how there will be a deformation. Close. So this was all about the designing new material or giving new material properties. Thanks.